guys, I'm Emma.
And Zoe.
Today we will briefly sum up all the information of Chapter 6, Dynamics. We would like to start the presentation by introducing two types of motion. It is divided into natural and unnatural motion. Natural motion is the movement of objects that arises from their nature, without the need for an internal force. Its subcategory are terrestrial motion, motion near the Earth, and celestial motion, motion of planets. And all motion other than natural motion was called unnatural motion, and was thought to require a field force to be sustained.
Now we will introduce some scientists who progressed the ancient dynamics. At first, Galileo established kinematic and inductively developed dynamics. He reached the conclusion of the effects of air resistance on falling objects. Also, he inductively asserted the principle of inertia, which states that an object in motion will keep moving unless an outside force acts on it. After Galileo, Isaac Newton followed his conceptual investigation. Newton's work grew from his study of gravitational attraction between astronomical bodies using differential calculus. Finally, he published his 3 laws of motion that define the concepts of force, mass, and momentum in Principia.
Dynamics is the study of effect of forces on the motion of objects. So now it is time to discover what force is. Push or pull belongs to the class of physical phenomena called force. All matter is held together by forces. Matter exerts forces and has forces imposed on it. It is classified as contact and non-contact force. We can find forces in our daily life when we press the key on the cell phone, breathe, swallow, walk, sit, or write.
Force does not always cause a change in motion. If the sum of all forces acting on an object is 0, then we say that the forces are balanced, which does not create any motion. Conversely, unbalanced forces change an object's state of motion. This is because of their differences in size or direction of force.
Equivalent force is the force that brings an object into a state of balance. It is equal in magnitude but opposite in direction to the sum of all the other forces acting on an object.
Now we move on to 4 fundamental forces: gravitational, electromagnetic, and strong and weak nuclear force. Gravitational force is a long-range force that is proportional to the masses of the interacting object and exerts its influence over theoretically infinite distances. Electromagnetic force is a type of physical interaction that occurs between charged particles. And strong nuclear interaction force binds quarks together in clusters to make more familiar subatomic particles, such as protons and neutrons. Lastly, weak nuclear interaction force doesn't hold things together or push them apart.
The central principle of dynamics has been summarized in Newton's law of motion. But before we move to those laws, I would like to clarify to you about weight and mass. Mass is an amount of matter in an object, while weight is the force of gravity on that object.
Now we know their differences clearly. Let's explore Newton's law of motion. Newton's first law states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. Second law of motion states that the acceleration of an object depends upon 2 variables: the net force acting on the object and the mass of the object. Lastly, the third law of motion states that when 2 objects interact, they exert equal and opposite force on each other.
Newtonian dynamics has been validated for ordinary objects over the 3 centuries before scientists discovered that it does not holds true for particles that are extremely tiny or moving extremely fast. This is all for today.